using these two technologies only. And no great inventions have happened. It's basically innovation and improvements. So I have chosen at least 7 areas. One is, just to make sure I provoke enough interest in the people who are here. Some of it, I think probably you know it probably even better than me. One is the Internet of Things. How many of you heard about it? Internet of Things, IoT. Internet of Things, I'll just say what it is. It's simple, not all that complex. And I know how many of you heard about ultra high definition TVs, 4K, 8K? High definition TVs, yeah. So I think that's something I am able to really reach and then make some impact, I hope. And another one is the wearable technologies. Wearable technologies. Somebody has some idea? Probably, I think, Professor, you will have something. Because it basically, it's to address your area of interest. And probably the fourth one is the smart cars. I'm sure, many of you would have read in the paper last week, I think Audi car, is planning to drive its car from San Francisco to New York. So it's about 5,006 kilometers without driver. So smart cars. And then unmanned air vehicles. That's probably is the area which I am interested in, as well as automotive. And the sixth one is three-dimensional printing, 3D printing. Anyone has any about it? Probably mechanical engineers will know. Yeah, 3D printing. And the other one is something which we have been hearing over the years, cloud computing. So when you look at each of these, I'll start from the Internet of Things with a simple example. We know for sure, the computers across the globe are interconnected very well, by which we are able to get access to any server which is there miles away from us, and then we're able to pull out the information. We're able to communicate using mobile and so many things. But then basically it is within the internet communication, I would say, the domain. But just imagine you're able to communicate to a device, a gadget, which you use it in a day-to-day, let's say a fridge, an iron box, or a television, or a mobile, or anything. So that means now the innovation is already reached a level where I think they are able to make the things gets connected. That is called Internet of Things. Anything you can connect. What is the advantage? How it really came about? Just because I think we are able to add lots of smartness, intelligence into that gadget, anything. Similarly, we are able to make it communicate to another one, device-to-device communication. So what it means, let's say, just imagine, okay, you have a guest house somewhere in a hill station where you have it's under lock and key, where the key is with you. Just imagine, whereas you want to give access to one of your friends who is going to visit the hill station to go and then stay for a while. So just think of putting an intelligent smart lock there, which I think you can easily conceive. Just put a small lock there, which has got enough intelligence. Maybe it is half the size of a mobile phone. You fix it onto the door. You can just imagine the different advantages you can gain out of it. Maybe you can pass on, instead of handing over the key physically to your friend, you can pass on the code to him through mobile phone. So he can, using his mobile phone, he'll be able to operate the lock. And then you can keep a track of when is he opening the door, when is he closing the door. You can imagine anything, you can do it. So much of advantages can be got about. Even, you can lock it so that, if somebody, a burglar is trying to infringe and then open the lock, then you get an alarm. There are so many ways you can think of. So that's a kind of situation, the whole world is evolving. In another 5 years, I think most of us will have some form or other an item which is made by this technology. The challenge today on this technology is how to give it to a common man at an affordable price. This is the challenge across all innovative and invention areas, which I think Professor will agree with me. And second thing is about the ultra high definition television, I think which I don't think I need to dwell about, because we all know of high definition television, which I think is slowly catching, it's already there in many homes, and the transmission is also there. But I think a couple of weeks ago, I think it is, if I am right, it is Tata Group, which has come up with 8K transmission, that is 4096 by 2160 pixels. So if you really want to view that kind of television at home, then you need a large screen, 55-inch screen. And then, the content also has to be delivered. So today, this kind of technology is just emerging across the, in the Western countries, so which is already there in India. So it is already, 4K technology is in the air. And if you want to really buy and view that nice pictures using that ultra high definition television, you can do that. Maybe that's a technology which I think you can easily understand and appreciate. But the innovation that is behind this, all the speed, performance, which are associated with the communication as well as with the semiconductor technology. And the third thing, which I wanted to talk about is the okay, I think I may not be probably going in the order, but another thing which I want to talk about is the 3D printing. The 3D printing. 3D printing is nothing but three-dimensional printing. Let's say you are using we are using a lot of gadgets at home, and then maybe suddenly you find while turning the knob of the television, which you don't do nowadays, maybe knob of a mixie, it breaks. Maybe it's something which you bought 10 years ago and it was a very valuable item, but you are not able to get the spares. So today, what you do is, if you take that device to a 3D printing machine, it can easily profile it and then create it one for you. How does it do? It does by incrementally adding layers one after the other. That means just imagine that knob of that mixie is cut into small millimeter level cross sections. And then using a machine, you can probably stack the layers one by one to bring that shape. So this is again at a level where it is really, their machines are there, available in the market, and they are working. Only thing is affordability. So at a point in time, I think you will be able to go and then ask from a shop, yeah, I just want you to get this thing done for me, like you Xerox or you take a color Xerox today. So that's the kind of technology which is now really emerging. And another one which I did mention is the on the automotive industry, because today I think in India we are seeing a lot of luxury cars, which are brought by BMW, Audi, and Mercedes-Benz. So what it means, today I think one cannot imagine driving a car with a driver, especially even, I think we are working on a program in Tata Elxsi, called Adaptive Driver Assist System, where we have certain understanding with some of the leading premier car manufacturers in abroad. So they said, okay, all this is fine, but we are really wondering how it is going to work in India. Because, even with a driver, driving is not all that easy, because, if you really know the rule to drive, I don't think you can really drive it successfully in India. So you should know how to simply violate rules, then I think you'll be able to drive it successfully. So while that's the lighter part of it, so the move across the globe is to have more cars which do not need a driver. The reason is because people are so busy, they don't have time. So they sit and then spend about 1 hour, 2 hours to reach their home workplace by sitting in the car. So they can leave it to the sit in the driverless car and then sit on it and then reach the destination without any problem. But while on the way, they can read the newspaper or they can work, get connected to the office server, and then you can work gracefully. But how all of this is possible? All of this would need, simply, I will just give a very rough idea about how typically a driverless car work. I think some of you or most of you probably aware of how the radar works, right? Radar. So, radar emits electromagnetic waves. The bounced back signal from the target is an indication of the distance of the object and possibly how that object is stationary or moving or at what speed it's moving. So, but of course, radar has got certain limitations, but then there is another sensor called LIDAR, basically using lasers. Where laser, the advantage is, of course, it will be able to tell you, again, it hits the object and then bounces back, by which you can really get a feel of how much distant this object is, and then even the size of the object, all of that. So all of these technologies are put together and then able to provide their information to the intelligent system in the car. There is no driver. So there are sensors covering all 360 degrees of the car. So it always, scans the whole terrain. It has to do it in fractions of seconds and make the terrain information available. Then you have the GPS information, which provides you the exact latitude and longitude information from where, you can really figure out whether I am in Marthandam or Thekkalai. And then I'll be able to, if I have a huge, large terrain map stored in the computer server, then I will be able to relate it and then make the drive successful. So broadly, there is a concept in which this driverless cars work. So one is the sensors, which are cheap, powerful sensors, and then the computing environment which is created in the car, which will have about hundreds of microprocessors in a car. Everything, every item you touch in a car will have a microprocessor. A handle has a microprocessor, the steering has probably multiple, the brake has multiple, powertrain has multiple. So all of this is becoming possible because of the feature dimensions which are able to bring down to a very level, and also a level where you can afford to easily have them fitted into a car without paying too much of price. So just I just want to give you the flavor of that thing, that yes, the smart cars are available. It is possible. I think you are going to see it probably in next 10 years' time in India too. So all of this, are kind of innovation, because while there could be some inventions at a very primitive level happening, but most of it is all innovations. And other one, is the dragons, or which we call it as unmanned air vehicles. I think which right? I think even Trivandrum, I think a couple of months ago, I think somebody, for fun, flew a drone. That is, just imagine flying an aircraft without a pilot. You can imagine the advantages of having it. Of course, it will have lots of regulation. It would need a lot of regulations, because you cannot just fly an object in the air without getting approval from the concerned authorities. But still, just imagine the kind of advantage you will get. The Amazon, that company, that .com company, has created an airplane. I'm right, it's called Optocopter, if I'm right. I think it has gone through all the Amazon forests and then took a picture, because Amazon forest is something, you cannot even think of, getting access there. It is such a dense forest, never ever anybody had explored. So it has gone around the Amazon forest and then took photographs and then made it available. But just imagine how that UAV is flying, the Dragon is flying. Because while flying at the very low altitude in the Amazon forest, it should look for, very smart ways to avoid any intrusions, So all of that is there. The collision avoidance systems are built using all powerful sensors and other things. So all of this is, really there. I think even India also, the National Aeronautics Laboratory is building UAVs. Of course, it has got multiple purposes. It can be used for security purposes. It can be used for farming. It can be used for, terrain mapping, so many things. So that's all advantage. So maybe in the few years to come, you will see those technologies very handily available in India. And the last one probably is something which will be of interest to the people who are in the computer science department, the cloud computing. Cloud computing, I think the jargon looks fairly complex, but it's fairly simple. The basic concept is, you have very good level of connectivity across the globe. So that means, let me say, I have a powerful server which has the ability to do very intensive computations for a specific purpose for which I am using it. But it is not that I am going to use that computing power all the time. Maybe there is somebody in Europe or somebody in US who cannot afford to have that computer, but still is looking to for a computing power to solve his problem. Even I think sitting in Singapore, I think if we in the college have a powerful computing setup, service, I think he doesn't have to really create an infrastructure to solve some of his problems. So we can offer it as a service. This is simply possible because of the internet connectivity. So this is, why it's called cloud is because whatever power you have in the computer system, what you have, it is add to the cloud, and from the cloud anybody can pick up. It's just not that it can be picked up without any rules or regulation, but of course there are certain means by which the access rights are given, and then they can access. Information can be shared across. Maybe you can have a parallel computing when certain, for example, meteorological weather prediction is supposed to be one of the most challenging computer-intensive applications. So maybe it's just not possible to meet that kind of requirement by making one very complex, powerful server available. So you can harness the power of servers across the globe and then solve some problem in some server in one corner of the world and another corner of the world, and then bring them together and provide it. So this is nothing but the cloud computing. So the point is, I think most of this are happening, or the innovation. At least I am seeing, for the Consumer Electronics Show, which happens in US every year, I think somewhere in the February, January timeframe, 2013 to 2015, I think this has been the technology which has been widely talked about. The product companies are able to come up with a good product, which are very cheap, very efficient. So I think good that, we are in an era where we will be able to consume it. So I just wanted to conclude, the whole thing by just saying, I think people like me, and maybe I don't know whether I can take the liberty to take some support from me, from the people in the dais. At least I happen to be in an era where I looked at how things were primitively, the kind of technology that was available primitively, the immature level of technology. Because, I don't know how many of you will believe me, I think even in my MTech, I think there were hardly 10, 11 engineering colleges in the whole of Tamil Nadu. So when I did my MTech in engineering, I found all the syllabus, what we have studied till my first year of MTech was using vacuum tubes, not even semiconductors. So fortunate, I think the second year we managed to get a feel of what semiconductor is. But today the technology which I am dealing with is far, complex and than what I have been dealt with years ago. So I'm really fortunate to see that kind of, the growth. But I think so maybe, people like me, have to really leap from a very elementary level to a very, very high level. But now I think for this generation, especially the kind of people who are sitting here, the platform is very beautifully created, an excellent opportunity is given. It's all absolutely by hopping from where you are there today. So you don't need to struggle, maybe too much to understand what technology on which these things have happened. Maybe it's a good thing to get an appreciation of how this technology evolved. You certainly can take advantage of hopping from here. But then where will you grow? It's limitless, boundless. Multidisciplinary, boundless growth is an abundant possibility. So I would like to conclude just by saying, that hop from here, grab the opportunity, and I think sky is the limit. Thank you.
Thank you, sir, for providing valuable insights on various innovations in the key areas.
Professor V. Suresh, Head of School of Electronics and Communication Engineering, is here for honoring the keynote speaker, Mr. Rajeshekar C., with a memento as a token of appreciation. I invite him for the same.
Now we continue with our second session. For this, I invite Professor Anish John Ball, Head of School of Electrical and Electronics Engineering, for introducing the next keynote speaker, Professor Dr. M. Shivaprakash, Director of Research, Nurul Islam University.
A very good afternoon to all. It's my privilege to be here for introducing our keynote speaker, Professor Dr. M. Shivaprakash. Dr. M. Shivaprakash is the Director, Research and Dean Faculty of Mechanical Engineering in Nurul Islam University, Kumarakoil. He has 17 years of experience in teaching and industry. He completed his BE Mechanical Engineering from MK University in 1996 and ME Production from Annamalai University in 1999. He completed his PhD in Manufacturing Engineering on 2008. His areas of research is material synthesis and characteristic studies. Presently, he is doing research in coating of magnesium alloy and composites for aerospace and biomedical applications. He is the principal investigator for a research project in the area of coating funded by DRDO. So far, 3 scholars have awarded PhD degree and 8 more scholars are doing research work under his guidance. He has published 40 papers in international journals and 5 papers in national journals. He is in the editorial board of 2 international journals and regular reviewer of 3 renowned journals. He has organized number of conferences and workshops in the emerging area of mechanical engineering. We are much happy to have such an eminent personality to present the keynote address. So now I invite Professor Dr. M. Shivaprakash for the keynote address.
Good afternoon to one and all. Thank you for your nice introduction. And first of all, I wish to thank the organizing secretary, the principal, and my friend Dr. Austin, the director of this institution, for inviting me to this conference. So in this conference, I would like to deliver a keynote address in metal matrix composite by powder metallurgy route. Introduction, let me see about a slight introduction about the metal matrix. Materials and process development played a crucial role in the development of the nation. You know, for example, we take a automobile sector, that is a 2-wheeler and 4-wheelers of the present new vehicles, and compare it with the 4 decade back vehicles. If you see, means the efficiency, fuel efficiency and the comfortable of the present vehicles are very good and better than the previous one. Do you know the reason behind that? One is the technology. Second one is the role of material. Because technology means in recent vehicles, we go for MPFI for petrol engine and CRDI and turbo something for the diesel engines. Is it right? And second is the materials. In the olden vehicles, cast iron is used for the engine, blocks and other things, so on, oil casings and everything. Nowadays, aluminum and aluminum composites are widely used. It is also one of the major reasons for the enhancement of the fuel efficiency and comfortable of the vehicle. So, to make these things, high strength, low weight, high strength parts for the successful operation of any equipment. So, the research for developing of new materials and process are going on still date. So, the characteristics of a good engineering material that should possess a toughness, fatigue, strength, modulus and so on. So, one of the advanced material is a composite material. So, it states that consists of 2 or more physically distinct and mechanical separable parts. For simple example, is a concrete is one example, another one is a tire. You take a concrete means it is a mixture of sand, cement and gravel. Okay. On mixing, this cement become a binder and as a coated over the sand. But each particles are distinct on the same property. They have similar chemical properties. There is no change. Similarly, if you take this tire means the outer is a rubber and the inner area is also rubber. But in between these two layers, steel belts, some other piles are there for cushioning effect and long time life. Okay. So it is a best example for a composite material. So the composite material consists of a reinforcement or a matrix. Here the rubber is the matrix and the reinforcement is the steel belt and piles. So basically it classified into three: metal matrix, polymer and ceramic composites. Metal matrix composite, it has two phases. One is a matrix, another one is a reinforcement. The reinforcement may be in a type of particle or fiber. The fiber may be a long or a short fiber. So this is an example for a fiber and aluminum matrix composite. The matrix material, mainly 4 alloys are broadly used as a matrix material in the composite. One is the aluminum matrix, and aluminum is a very light material. It has a density of 2.84 gram per centimeter cube, and this material has an excellent strength, toughness and resistance to corrosion. So in the advanced equipments and recent equipments, mostly they use the aluminum alloy and composite. So a lot of research is still going on developing of new aluminum composites. Another one is a titanium matrix composite. This material is withstand high temperature because the melting temperature of aluminum is 660 degrees centigrade and density is 2.84. But titanium melting temperature is 9,950 and its density is 4 gram per centimeter cube. That is the disadvantage of titanium. But this material is highly applicable for the high temperature. Next one is a magnesium. It is one of the lightest material. Its density is 1.74 gram per centimeter cube. Which one is the very, very lightest among all these 4? And its melting temperature is around 660. And after 1990 decades, that is from 1990 onwards, a lot of research is going on this magnesium, which one is recently replaced the aluminum composite also. Next one is a copper, mostly applicable for electrical and conductivity applications. So these are the reinforcement materials.